Okay, I guess we can start then. Good. So, first of all, thanks very much for coming here and not to the kind of superstar thing that's happening next door. What I'm going to talk about over the next 45 minutes or so is how I think over the last 4 or 5 months, some really, really interesting kind of developments in technology that's available to us emerged that allow us to hopefully change the entire economics of how we test software with a lot of front-end stuff. The components for this have been popping up for maybe 5 or 6 years in different places. So none of what I'm going to talk about is a revolutionary new idea, but what I think is really, really interesting is how these things really started coming together over the last, as I said, 5-6 months, and what we can kind of start using for this. So some of the stuff I'll show you, we're actually using on a product that I'm building, and we took a bunch of scripts that evolved over the last few months and actually open sourced it as a tool. But don't worry about the tool that much. It's kind of the principles and kind of the ideas that you can use with a ton of other stuff on your own products that are important. And if what I show you does look nice, again, the tool is, at the moment, I reckon, in an alpha stage, which means that it's useful enough for us. It's probably not useful enough for 100% of your use case, but if it's 90% there, that's why GitHub is there. So, tweak the 10% and commit. So one of the kind of things I used to do in my previous life before this tool started taking off is I worked a lot as a consultant helping people figure out how to do testing correctly in short iterations. And kind of that took me to lots of really interesting places. I worked a lot with banks, insurance companies, but I worked with some weird companies as well. And one of the weirdest engagements I ever had was a fetish sex website in Germany, where kind of they were trying to figure out how to test some improvements that they had on their front page. Now, I'd love to kind of show you a screenshot of that, but I'd probably get kicked out of the country for that, so kind of this is going to have to do. They were replacing the front page with something that allowed people to easier find other people interested in similar stuff. Now, this is a site for people who want to do horrible things to other people or people who want horrible things done to them. So what they were trying to do is kind of, customize the header picture to show something that's appropriate for your preferences. And then there was a bunch of checkboxes here, kind of the stuff you like. And then they were just putting random shit here that, who knows, you might like, you might not like, and mixing that up. And the problem they had is that because this is so kind of fringe, nobody was finding lots of matches there. So they were trying to kind of improve matching. And first of all, this was completely blew my mind what these guys are kind of doing and the domain. But one of the things that was really revolutionary for me there is they were treating wireframes much differently from everybody else. Where with everybody else I worked before then, wireframes were, God-sent requirements from the designer. This is how it has to look like. And normally you would get kind of one wireframe per web page that's explaining, how everything is positioned and where it needs to go. And that's basically taken without any discussion. Now, what these guys were doing actually is because this was so fringe and there were lots of ideas they were throwing around, they took these wireframes and then developers and testers and designers were kind of playing around with this stuff to find edge cases and to find kind of the business rules, in a sense. So kind of this was fascinating for me because what they were doing is they were treating wireframes very much like banks, insurance companies that I worked with would treat examples coming from the business. So kind of the whole spec by example or BDD or kind of customer-driven tests, for them wireframes were the examples. This was fascinating to me. I mean, maybe if other people work in different companies that already do this, it's not that important, but I never really thought of wireframes as, hey, here's one example of how it's supposed to look like. Let's go and find all the edge cases there. And that became a really, really powerful thing to think about. Later, I worked with a media company where they got a wireframe for how they want to display news. And I said, well, you can do the same testing heuristics on this that we normally do on kind of, spreadsheet examples. So you look at, well, where are the entities? Well, you have a picture and you have some text. What are the boundary cases? Well, what if you have 2 pictures? What if you have 0 pictures? What if you have 2 pictures of different sizes? What if the title is too long? What if the title is too short? What if the text is shorter than the picture? And a ton of these things that would normally come out when we start discussing business examples, actually, I realized we can do on wireframes. And wireframes are just examples of how something is supposed to look. They're not requirements. They're not kind of God-given. They're kind of a starting point for a discussion, much like anything else. And this tool that I'm building now, it's a mind mapping tool where most of our users ended up, for some reason, being schools. And although we started building it to scratch our own itch, given that kind of most users are in schools, that means I'm not a representative customer. And when we start getting these requests, it's very difficult to know what the actual kind of user needs. So we started doing lots and lots of interesting user research and realized that all of these kind of ideas for features that come, well, the best possible way to communicate with people is let's just start throwing out some examples. So about 6 months ago, we started working on this idea that maybe we don't want to do just kind of hierarchical mind mapping because people wanted to start connecting different ideas with arrows and things like that. So kind of the basic example we connected is something like this whole concept mapping thing that's a slightly different visualization. It's kind of interesting for this use case, but the critical difference between a mind map and concept mapping is you don't have a kind of breakdown hierarchy, you have arrows with labels going all over the place. And we started kind of, okay, this is our kind of, this is what we need to do. This was our user story. This was our requirement. This is kind of, but from that perspective, it's just a wireframe. It's an example. There's edge cases there, and we can use our existing testing heuristics that evolved over the last 30 years to kind of evolve requirements from here. So I have variables here that's kind of the number of nodes, the length of the line, the text here, and then we can start playing with edge cases. What if this text is longer? Do I extend the line? Do I break it into multiple lines? How many lines? And all these things. And then we started realizing, well, it's not just the kind of the text there. You can have maybe one node connecting to 2 nodes. That's another example. And is it supposed to be like this, or is it supposed to be like this? And this kind of started really, being a big challenge because I don't really use concept mapping. We had lots of customers requesting that, and we realized we cannot answer this question. So, and this is a very, very similar situation to, when I worked with banks, and I'm not a domain expert, I can come up with a bunch of examples, and the best thing I can do is kind of offer it to business users and say, we can do this, or we can do this. Which one? And kind of thinking about wireframes as examples became really, really powerful to start kind of evolving that. And luckily, because this thing started taking off and we had lots and lots of people interested in this, we had about 1,000 people who were really keen on helping us figure out what to do. So we came up with a Kano survey that's pretty much like this. Hey, here's 2 options, which one? And then we had 10 or 15 screens like this. And then people voted, and we analyzed what they do. We interviewed people about this, and we came up with something that was essentially about 10 times simpler than what I thought we need to do. Because we started discovering new requirements. Because we were using wireframes as examples to kind of elicit requirements, not as requirements themselves. And kind of, this is a fantastic kind of part of what in the development community we normally call behavior-driven development or spec by example. We have these examples, they help us evolve the requirements, we have a good conversation, and kind of the part that's really missing from here is kind of when with typical behavior-driven development, with typical spec by example, you end up with a nice spec like this, and then you can actually run it as a test, and you can say, well, this thing passed, this thing failed, I know if I'm complete or not. And kind of, we thought, well, this Kano analysis that we sent out and people voted and then we interviewed people kind of the winning combinations are actually our spec. That's what we need to do. That's what we promise to people to do. And from that perspective, you know, we're almost here, but we never, ever, ever do automated testing on wireframes. And kind of, then this kind of really started, you know, bugging me, like, why don't we do this for UI examples? Like, if wireframes are just UI examples, why don't we kind of close the loop? Because then we can do our kind of feedback better. We can, you know, in this case, this is a consumer-driven product, so we don't really have lots of stakeholders that need to approve or complain. But in other cases where I say, you know, I've mentioned this media company, they had lots of designers that were all arguing about this and business stakeholders. They came up with some wireframes 2 months before the development started. They pushed it into development, and then kind of course, it went off the rails, but they were reviewing the wrong things. If they had their specs as UI examples and they were able to validate and close the loop, then maybe designers would have been able to get involved the same way kind of business experts domain experts can get involved in the banks and provide quick feedback. We can speed up the feedback quite significantly if we can do this. Now, we started looking at why, you know, why cannot we do this for UI examples? Because kind of nobody's doing this for UI examples. And kind of very quickly, you know, we ended up concluding that this is impossible because of how UI testing is done. And, you know, at NDC and many other conferences, you have people every year talking about how UI testing is problematic, especially kind of if you're here from a developer perspective. Most UI testing tools are designed for testers on a different continent. They're designed to optimize hiring 500 people to click through something and record it, which, you know, as a developer makes me vomit. So it's something that is horribly difficult to maintain. It's something that we tend to avoid as much as possible. And kind of I went on, you know, many stages like this over the last 15 years and told people just don't bother with the UI testing. Like, test below the UI, leave the UI for exploratory stuff because it's not worth it. Because, you know, the number one rule of UI testing is going to be slow. So don't just, you know, as a developer, you don't care about slow tests. Leave it for somebody else, or kind of automate as much as you can. The second rule of UI testing, I think, that we've come to accept as an industry is that UI testing is brittle. So UI tests change. If you have a UI test and then you change a link into a button, everything breaks. And then you have to adjust everything, and that takes a lot of time. That's painful. So even when people invest a lot in UI testing, they end up throwing it away. And kind of the third thing with UI tests, especially with automation, is that we've accepted as a rule that generally, kind of regardless of how much you automate, stuff can go wrong on the UI and the automation is not going to catch it, because automation can only look for things it's trying to look for. And if you're not looking for things moving a couple of pixels, or if you're not looking for changing the color, then horrible stuff happens in the UI. And the UI is completely broken, but your tests pass. So we've kind of accepted these things as something that is given. And if you look at, you know, UI testing articles online, what you find is kind of this ubiquitous pyramid that ends up being, oh, you know, 90% of your tests, 50%, whatever, you know, is unit tests. Then you, as you go up the level of the UI, you know, start reducing it, have only few tests that go end-to-end. Now, there's 5 million variants of this pyramid. It's whether the top is end-to-end, or whether the top is UI, or whether the top is kind of acceptance. And generally, kind of, all these articles talk about how you should have only a few UI tests, end-to-end tests, and they're brittle, so you're going to suffer, but that's okay. Test everything below the UI. Now, the problem with something like that, especially for us, is that most of what we provide is good UI. So if I test everything below the UI, but my critical competitive advantage is good UI, then I'm not really testing what I need to test. And in my previous life, I studied maths for no benefits whatsoever apart from just postponing mandatory military service. And one of the things I was kind of really interested in there was geometry, and how kind of about 200 years ago, some people independently in Germany and Hungary kind of took stuff that kind of the civilization took for granted for 3,000 years and found a bug in it and found a loophole and basically turned it on its head. And the rules of geometry that stood for thousands of years were defined by Euclid, who assumed that parallel lines don't touch each other and they're always at the same distance. And then 200 years ago, somebody said, well, what if that's not true? Can we, if we flip the context, do we get something that falls apart, or do we get something that kind of still holds water? And they actually came up with changing the context, something that is now very, very useful for space travel and things. So they changed kind of geometry. So I was thinking, like, is this really set in stone, or is this just our current mental constraints? Because we're not thinking about space travel. We're seeing parallel lines here at the same distance, so that's not a problem at all. And that's why I think kind of these things are not really rules. They're kind of the Euclidean axioms of UI testing. And if we can flip the context, if we can change the context for this stuff, then pretty much all of these things can be worked around. And that's why I think is kind of happening with current technology last 6 months, last year, because there's some really interesting kind of new releases in popular software that allow us to kind of flip the context. So kind of, I'm going to tackle this one by one, and kind of the first I want to tackle is kind of the whole brittle thing, because slowness is something that we can work on by throwing more hardware at it. That's not a problem at all, but brittleness is where humans need to get involved, and throwing more humans at a problem is never really good. So kind of in terms of brittleness, the big problem with, as I said, most UI level testing stuff is that the UI level testing stuff tends to be, oh, I'm going to record my interactions with this, or I'm going to kind of put it on a video. And there's some really interesting tech emerging in the market. For example, I was in Vienna 2 days ago speaking at a testing conference, and there's a guy who is developing an artificial intelligence kind of monkey to click around the software and find coverage paths to open up all the screens and then kind of record what's going on and try to kind of look for regressions and things. It's kind of really interesting stuff that's emerging there as kind of how can we record our stuff better. But I think as long as we're getting into this record and replay mode, that's, as a developer, kind of, it really feels horribly wrong, because every time a tiny thing changes over here, I need to go and re-record all my tests. So that's, just incompatible with my brain. I don't want to do stuff like that. And kind of, if you look at the language where we're kind of describing tests, so, Selenium has, open, click, 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 open, click, 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 CSS, 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 yellow. And then if anything breaks in between, you're screwed. So although this is amazingly good to keep people busy, it's horribly bad as a way of maintaining. No, it's not kind of Selenium. There's lots of good use cases for this. Selenium is a really good tool, but this way of describing tests is just bad. And for some insane reason, testing managers in large organizations love this stuff, because they're trying to optimize the process of writing a test. I've been in a couple of sales sessions where, people peddling some kind of heroin testing tool show, oh, look, I can record the test. Amazing stuff. And you don't need brains for this at all. Like you can get somebody, who's a student. You can get somebody who doesn't speak your language. You can get, it doesn't matter, get aliens, get amoebas to kind of click through this, and you have a test case. It's amazing stuff. And then people buy that, but kind of, for me as a developer, the time to write a test case is really not a problem. The time to maintain the test case becomes the bottleneck. And especially with automated tests, I think, the more I think about this kind of over the years, the more I realize that automated tests tend to be valuable when they fail, not when they pass. When an automated test passes, you're not doing anything. There's 5,000 tests, you run the build, they pass, nobody does anything. But 5,000 tests, you run the build, and 2 of them fail, that's when humans jump in to investigate. So optimizing the process of writing the test is completely wrong. Optimizing the process of troubleshooting it, optimizing the process of reading it, is where we can save a lot of time. So this is optimizing how we write a test. That's wrong. Now, as an underlying technology to drive the browser, Selenium has a lot of value, but not as a way to describe the test case. That's the key thing. Now, there's some other stuff that emerged that's really, really interesting, where people were talking about, don't worry about this click, 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 and then something changes from button to a label that's difficult to maintain. And the next generation of tools like this was something like SQL, where you can actually clip things. So if a button changes to a link, you just clip that and replace it in the file system. It gets replaced in the test. And kind of, although that's reducing the cost of maintenance slightly, it's still difficult to understand when it fails. It's still tied too much to kind of the whole process of clicking and interacting with the site, and it's too brittle. It's just too brittle. So kind of we started looking at this, and I realized kind of this is a completely wrong way of describing tests, not just UI tests, tests in general, because if you look at something like, a recipe for a scrambled egg, you say, well, first you beat the eggs, then you do this, then you do this, then you do this. But I can bet kind of all my money that nobody who goes into a restaurant when they come in and say, well, what would you like to eat? Says, oh, first thing I'd like you to do is kind of get some eggs and then break them and then, spin them around and then cook them for 30 seconds and then do this and do this. See, like our scrambled eggs. Like, I really don't care how you prepare them, just bring me scrambled eggs. And if your, heater doesn't work that well, then, figure out how much you want to cook it. If I tell you 30 seconds, I have no idea how much this thing is going to work. So maybe it's going to be overcooked, maybe not. So, bring me scrambled eggs. And good test cases tend to focus on the intention. They don't tend to focus on the implementation, because we want them to kind of be independent of implementation, so that if we run it on a slower hardware, they're okay. If we run it on a faster hardware, if I run it in Chrome, if I run it in Firefox, I want to test the intention. I want my test to be this stuff here. So kind of from that perspective, the kind of BDD spec by example community talks quite a lot about the distinction between what you put in the spec and what you put in the automation layer, where kind of the guideline is that your spec, your examples are what you want to test, not how you want to test it. And the automation layer is how you want to test it, but not what you want to test. By splitting what and how, we make things maintainable. We make things easy to understand. Because if a link changes into a button, I flip it here. I've changed the process of testing, but my test is still the same. If I change something where I'm no longer using decimals, I'm using kind of strings, that's fine. I change it in the process of testing. At the same time, because I've decoupled what and how, I can reuse the same process for many, many, many examples. So I can add more examples, I can manage them easier. So kind of this is emerged as a relatively good practice to manage and maintain very large test suites. And the thing is, kind of, if we look at what we were doing, and this whole click, 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 or even this image, this image, this image, that's all talking about how we test stuff. That's not talking about what we're testing. So we started kind of thinking about this from a different perspective. Like, I really don't care how we got to the result, as long as the result is okay, but how do we describe the top level there? And then one of the things that we started doing is, because our stuff kind of renders into SVG at the end, I can say, well, if I'm doing the connector function, it should set the dash as if the line style is dashed. So I will set the line style to dashed, I'll chuck it into the system under test, and if the line style comes back as dashed, then this is okay. So that makes a test a lot more maintainable. It makes it independent of the interactions that led to that. But the problem with this stuff is it's almost impossible to maintain. And it's almost impossible to maintain because kind of we completely did it at the wrong level. These two things are simple, but then you start getting into some more complex examples, and more complex combinations starts looking like this. And a really interesting thing with something like this, it's like cement. It's like cement from a perspective that you do it once, and then when it hardens, it becomes really, really difficult to change. For example, what happened about a month after we did this stuff, we decided to change the fonts. Now you change the fonts, everything moves. Everything moves by a pixel left, 2 pixels up. It's still correct. And all these things, like positions and they are deterministic. But because all of this stuff moved, I need to sit down and recalculate them on paper to understand whether the expectation is right or not. If I really want to do TDD properly, then I need to spend 2 weeks recalculating all this stuff. And this is error-prone. My brain doesn't work that well. I studied maths 20 years ago. I can't add numbers anymore. So kind of like we decided, well, kind of should we just, I don't know, throw these tests away? But then if I throw these tests away, I'm flying without a parachute. So that's not a good thing as well. And we realized, kind of going back to this thing, that it's not even just what versus how. It's kind of the top of this needs to be in a human syntax. And the middle part is in kind of the machine level syntax. And if I look at something like this is actually a syntax error. From a testing perspective, it's a syntax error, because this is not what I promised to people. I've not promised to people that I'm going to deliver an SVG that has, when you put in these arguments, it has, translate 80 minus 20. What I've kind of started promising people is, well, this thing is going to be left of this thing is going to be top of here, this thing is going to be right. And we started looking at some other interesting tools. For example, Jim Shore built a unit testing tool for CSS that is cross-browser compatible, that allows you to kind of raise the level of abstraction. And you can say, well, the navigation bar is supposed to be 10 pixels above the bottom of the header, and it's supposed to be aligned with the left. It's supposed to kind of have the width of the viewport. So there's lots of these assertions that raise the level of abstraction significantly. And there's another tool that's really interesting kind of that came into that. It's called Galen Framework. Galen Framework allows you to kind of even do away with the asserts. And the idea of the Galen Framework is so that designers could engage with this stuff. Because designers are not going to be able to write this, but designers can theoretically write this stuff, as if, yeah? Bear with me for a sec. So kind of it's supposed to say, oh, well, on a mobile and a tablet, the comment section is going to have this width, and it's going to be inside the screen. So it's kind of readable. But, so this is kind of human syntax. But at the same time, this is suffering from the same problem that Selenium automation is suffering from. It's describing how we test something. It's not describing what we promise to people we'll deliver. Because what we promise to people to deliver is this, not this. Kind of, I don't want people to read all this shit. This is what I promised to deliver. This is what I need to deliver. And kind of, this is kind of the level that we need to work on. And the kind of the key thing here is that once we start thinking about this, well, the screenshot is something that we can automate and test, theoretically. Why don't I grab a screenshot and I can have my kind of expectations designed like this? I'll run the whole thing and I'll run and compare the screenshot. There's 5 million screenshotting tools out there. Now, the problem when you start thinking about screenshotting like that is automation really becomes unhelpful. Because yes, I'm going to take a clip of kind of this part here, but then we get into the problem of testing only the stuff I'm expecting to find, where UI stuff tends to be a lot more problematic for unexpected things. Is the hover now over kind of do you have a part of the screen that's moved too much? And all these things are tangential. You don't look for them. It's just weird when you start testing. And this is when kind of we ran into a really, really interesting case study from the video games industry. There's a generative universe video game that launched a couple of years ago called No Man's Sky. No Man's Sky is a game where you as a player were supposed to be able to fly to any of something like 18 quintillion worlds. And inside those worlds, you should find enough interesting stuff to play and play and play and play and play forever. And in order to generate that level of variation, what they started doing is they started modeling some animals, some buildings and stuff like that, and then they had random mutations for each of these worlds. No, not necessarily random, deterministic, but driven by kind of a process with a lot of different seeds. So, you know, on this world, they would say, well, the turtles are going to be red and they're going to walk on two legs and we're going to put a chicken head on a turtle. Or, you know, we're going to create some, I don't even know what this is, a mix of the alien and Stegosaurus with gazelle legs or something like that. Now, the problem with this kind of stuff is it's almost impossible to define correctness. Because it's supposed to be interesting and random, but you know, is it right or wrong that a turtle has the head of a chicken? I don't know. Nobody knows. Plus, when you think about these 18 quintillion worlds, even if you had the entire Google Cloud and AWS at your disposal, testing all that stuff is going to take, I don't know, forever. So kind of asserting correctness here is impossible in today's technology, even though the process is deterministic. And what they've done is they've done something kind of very similar to how NASA explores space. They've put probes that are software kind of probes flying around this universe, jumping to random planets, and filming what they see and showing that on developer monitors, just, you know, for a couple of minutes. And occasionally somebody would spot something weird and they would say, look, you know, this lion is too big, they can't walk on legs this small. Let's pause, let's figure out why we generated this stuff. Let's, you know, modify that and then regenerate that world and keep playing. And one thing that was really amazing for me here is that they realized that kind of the process of evaluation still needs to be left with a human. But the process of collecting all the data is what's tiresome. The process of collecting all the data is what's difficult, and they automated the process of collecting all the stuff by, you know, showing a probe that's flying through the space, and let the human make a decision whether this is actually good or not. And in retrospect, kind of I realized that what they were doing is they were automating to assist humans, not to kind of replace them. And going back to our SVG tests, what we ended up doing after about 3 rewrites is saying, okay, what I'm going to do is I'm going to generate all these documents, and because they're SVGs, I will look at them. And I will see if there's some weird shit going on. And what we started doing is thinking about, well, if we're kind of generating all these test mind maps and concept maps and just looking at them every time, we spend 95% of our time just generating them. So I can, you know, keep the part of the process where I need to actually make a decision for me. Everything else can be done by the machine. And this thing really started kind of lifting things off, because then we just threw away all these bad, horrible tests where we're trying to do -80, -50. I'm no longer even comparing that, because we now can compare visuals. So this is where, as I said, we've polished these scripts enough, and we've open sourced a tool called Appraise that's designed to get people to do approval testing, like human approval with some automation to collect the data. You can find it on the appraise.qa domain. QA is a domain. It's for Qatar. But hey, you know, doesn't matter. So I'm going to very quickly show you this, just so that, you know, it's not a total kind of theoretical thing. So if I connect to this, let me see if this is going to work. So this is our actual kind of product code. So we started building a bunch of these example pages, and in the example pages, let me see, so I was talking about connectors. So I'll show you the connectors. So on GitHub, we have kind of a test that says, an example that says without any properties, the connector just stays like this. Then we have a test that says kind of, if I set the color, I expect the connector to look like this. Then another example is if I set the line style, I expect it to look like this. And if I set the label, I expect it to look like this. Those are kind of some basic examples that can come from a drawing, from a napkin, from a wireframe, from whatever we want. And they're kind of in Markdown, so they render nicely as documentation for us to remind us what we need to do. But kind of, if you look at this stuff here, what this says is, this is how I'm going to execute the test. And this Markdown is at the same time a fully automated test, which I can run. And now I can do, and this starts kind of running through all these things and saying, well, for each of these things, I'm going to get the example you gave me, like line style dashed. I'm going to put it into the fixture. I'm going to go through this whole process of testing it, grab the clip you told me to grab, and I will compare it to what I got. And if there's no differences, you really don't need to care about this. If there is a difference, we need a human to look at this. So for example, if we change a font, I will change a font, all of this stuff is going to fail, and then somebody can look at this, or something is going to fail. So kind of so I get this stuff now where everything is kind of green, 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 and the connectors page says, well, you know, these things all executed. It's like documentation. Let me break it now. So this would be in source right connector, for example. So I'm gonna, I don't know, kill the dashes or something like that. So let me make the width. So I'm gonna make the width kind of larger. And then if I do now I'm getting a difference here, and it has no idea whether the difference is kind of right or wrong. But it's letting me very quickly review this, and it's going to say, well, you know, for this particular example, hey, there's something wrong. Don't worry about all these other grayed out pixels. Worry about this stuff here, and then I can go into this, and I can say, well, you know, this is your expected, this is your actual. Is this what you wanted to do? Like, if we want to get connectors to be thicker, I don't need to go and recalculate 5 million SVG points. I can say, yeah, this is okay. Or I can say, oh shit, this is not what I wanted to do, and go back to this. And you know, from this perspective, what I can do then is I can just approve this example, and what it does is it takes this thing, that becomes the next expectation. If this is okay, this is not okay, then you know we do something. So we've kind of automated effectively to assist humans. There's kind of some really cool stuff we built here, like you can change the opacity of expected and actual. You can put them side by side. You can kind of show the diff and things like that. It's all designed to allow me to very quickly make a decision. Is this right or wrong? Because humans get involved when tests fail. And I want to optimize that process. I don't want to optimize the process of writing a test. But by kind of splitting what and how here, I've also enabled myself to reuse the same process of automation for all these 4 cases. If I want to add another case, it's trivially easy. I just kind of have so I kind of go down and I say, well, you know, I'm going to set another case here that is, come on, what have I done? So we're going to say NDC London. And if I set the label to be so I've not provided any expectations here because I really don't know what's going to come out. And when I run it like this, it's going to say, well, you know, one of your tests failed. And now we have an NDC test that says no expected result is provided. Here's what it looks like. Is this okay? And I can say, yeah, that's okay. And that becomes my automated test. I've not kind of spent 5 hours calculating the actual SVG points. It's something that I can now take in. Now, as I said, this thing is relatively raw. It's designed for me. I'm a command line freak. I like doing stuff on the command line. I can now approve this. And I can say, approve. And now when I run this stuff, it kind of works okay. And then if I do a connectors MD, what you'll see is kind of it took something and it put it into the kind of expected result, and that's it. Now, as I said, it's designed for me. I'm a command line freak, so I don't mind playing around the command line, but I understand this is not what most people do. But this is 90% there. I'm working on an interactive website where a designer would be able to review this and say, yes, I approve. Click a button. And because this is Markdown, it's all in version control. I can tag branch merge. I can have different versions of this. I can have all the benefits that as a developer I'd expect from a testing tool. Instead of, going to record and replay and having some, horrible script saved on some server somewhere on somebody's laptop that I have no access to. I can do all sorts of weird things with this because it's in version control. Now, kind of there's, what this means is this is no longer brittle that much because it doesn't take too long to spin it around. And it's no longer kind of that problematic from a perspective automation isn't that useful because this will, look at the whole thing if I want to look at the whole thing and just show me the diffs. So I will, look for unexpected things as well. But kind of that brings us to the last point of it's slow. If you want to launch a website, if you want to do, by the way, the reason why this is possible now is Headless Chrome got released a couple of months ago. Before that, we had Phantom.js, and Phantom.js never really worked completely as normal browsers. So there were JavaScript differences, there were CSS differences, and the fact that something passes in Phantom.js doesn't really give you the confidence that it works. Plus, Phantom.js never implemented ES6. And then we had, a testing code that would say, well, if Phantom, then do this. If not Phantom, do that. Well, screw that. That's not real testing. I can run this in Chrome, the way my users see it. And I'm actually doing it in Chrome. This thing launches Headless Chrome, takes screenshots and stuff like that. Firefox kind of released a headless version in the nightlies. So that's coming to a production version soon as well. Which means that, we can cover quite a nice user base with actually how they're going to see this stuff. And unfortunately, as I said, run a website, run lots of code, capture the screenshot, it's slow. And it's always going to be slow. So as a developer, I've been trained to think my unit test is, below 10 milliseconds. I can run thousands of unit tests, get feedback quickly. It's useful. When I think of a UI test, I'm thinking of something like 2 to 3 seconds. So I'm thinking, well, I cannot possibly run 5,000 of these. I cannot possibly run 20,000 of these because they are slow. And this is where a really interesting kind of thing starts to come into play. Because if you think about this stuff, UI tests are not necessarily slow, they just introduce a lot of latency. What I mean by that is each individual UI test is 2 to 3 seconds. But if there was a way for me to run 50,000 tests in parallel, I will get feedback in 3 seconds. So kind of the slowness there is not as much as slowness as it is latency, and this is where, in order to run 50,000 tests in parallel, I need 50,000 machines. I don't have 50,000 machines. I don't have the economic capacity to do that. And yes, I can rent it on the cloud, but renting that on the cloud and keeping and paying for that reserved capacity is insane. Nobody's going to pay for that. Now, another really interesting piece of tech that kind of came out a couple of years ago, but really became usable last year, is AWS Lambda. With Lambda, you do not pay for reserved capacity. You pay for utilized capacity. If you use Lambda for 100 milliseconds over a 3-month period, you pay for that 100 milliseconds. If you use Lambda today for 3 hours, you pay for those 3 hours. It kind of gets away with the whole thing on its own. And kind of couple of, like 2 months ago, somebody recompiled Headless Chrome to work in AWS Lambda, which means I can now provision thousands of instances of my test like this, and I'm only paying for it when it runs. And this is dirt cheap. So kind of from a perspective of UI testing being slow, this thing is the Euclidean thing that changes the context. It's no longer slow and it's no longer expensive if we design it to work in this. Because I can, on a commit, deploy stuff to AWS Lambda. By the way, this is the URL you can get it from. I can deploy this stuff to AWS Lambda. I can pay for, 1,000 machines running for 3 seconds, and that's it. I get my feedback from all this stuff. Now, kind of, I've not yet plugged in the tool we're building into Lambda, but that's why I said, don't worry about the tool. You can implement this on your own for other stuff. Once I stop traveling like a maniac a bit, then I do plan to kind of just use the Lambda to generate screenshots. We've designed the tool so that it has a pluggable screenshot kind of module, because we wanted to put Firefox in it as well. Now we can put Headless Chrome in Lambda. Or, if you're using some kind of mobile device farm that can run your stuff on lots of different mobile devices, you can just take screenshots and use this stuff to say, well, on Android, I don't know, version 7,000,005 on a Japanese locale, this thing no longer looks the same. And then somebody can look and say, well, that's what I expected it to look like, so, go ahead. And we can kind of use these principles. Now, that's why I think kind of the time is interesting now. Headless Chrome came out a couple of months ago. Lambda became really usable last year. And, although most people still think they can't really use Lambda for production work because of compliance, because for testing purposes, it's perfectly fine. I mean, we do use Lambda in production as well, but as I said, even if you can't do it for your production code, why not play around with it for Lambda, for testing? So, kind of, this is where I think, this turtle, we can put lots of balloons on it and make it a badass turtle that kind of, although it is slow on its own, if we do 50,000 in parallel, then, it's 3 seconds. So I think kind of what we're getting to here are really UI unit tests. Something that I have thousands and thousands that kind of look at different parts, look at different examples that are really making it useful for me to do wireframes as examples and to use them as a kind of start of a conversation, come up with all these different ways of how data might modify how the UI looks, and then have something that in 3 seconds tell me, yeah, this is okay, or this is not okay, or a human needs to look at this. So kind of as a conclusion, what I think is different now is the components for this stuff existed a long time ago. People were doing diffs on images. That's not a problem at all. We had headless browsers like Phantom. We had ways to execute stuff in the cloud. It was just expensive. Now, kind of part of why this is different now and what we can do with it is we can really use automation here very much in the BDD style to improve the communication between different roles. I don't have to show a designer a script where they need to modify stuff by 10 pixels, 50 pixels, or kind of do all these weird assertion stuff. Give me a drawing. Like, draw it on a piece of paper. I will put it into the tool. I will show you the diff. And actually, we've done that a couple of times. I had a picture. We put it into the testing tool. We executed the software, and then we looked at it overlaid and said, well, kind of this looks OK. So let's approve the picture to go from then on. We have acceptance tests on a napkin. And kind of I think first thing that's really interesting here is when we start doing this stuff, it becomes really easy to change examples. You know, anybody can just take the existing picture, move it a bit in Photoshop, use an SVG editor, or even if, you know, draw it again on, like I have an iPad Pro, I can take a photo, I can, you know, draw something and say, I want it to look like this now. Then I run it, of course it's gonna fail. I look at the difference and say, well, that's okay. So examples become really easy to change. It becomes really, really easy to add more. I just add another line to Markdown. You don't even need to add an expected case. Run it, it tells you what it is. Somebody can look at this and decide whether it's right or wrong. It becomes easy to kind of keep focus on the important parts. Because, you know, if my interactions are important, I will have an interaction test. If I want to test look and feel, I can test look and feel with this. And we can split what and how. We can kind of evolve this in lots of different ways. And kind of finally, I think, you know, once I finish the UI and I have a push button for kind of people that don't want to use the command line to approve this stuff, this becomes a really interesting link with the designers. From a kind of developer perspective, these are tests you're not going to vomit about. These are tests that are not going to hurt your stomach because it's not record replay and it's really easy to change flow. I open up my script that kind of runs all this stuff. I change it where it needs to go. I'm not damaging 5 million examples. I'm not recalculating that. From our perspective, it's really useful for us as documentation as well. Like I can look at the GitHub rendered Markdown here or even this stuff and I can see, well, you know, these are the things how we discussed this 6 months ago. And we have a ton of this stuff for lots of aspects of our system. Because when we're changing something, I can say, well, this is how, you know, this is what we agreed last time. How do we want to change it now? So it's kind of documentation as well. Imagine if you're doing something like React or Angular and kind of all these components you're generating. Somebody needs to consume, well, here's the documentation. If you change this parameter, it's going to look like this. If you change this parameter, it looks like this. If you change this parameter, it looks like this. And it's not something that is difficult to maintain because you need to regenerate all the screenshots. This is kind of giving you automated documentation. And kind of the last really interesting thing I think here is kind of it becomes really, really easy to maintain these fixtures. Kind of it becomes, you know, it's code. I can do all my coding tools on this. I can maintain it using version control. And kind of, it's not there yet, but I think, you know, it's not too far to be designed for massive parallelization. It's kind of, the design is there. We just need to implement this parallelization. And to each point, we have flipped the context. And these things are no longer kind of that slow, brittle, and difficult to maintain. So that's kind of pretty much it. I'll hang around if you have any questions, but I think it's lunch now, so I'll let you go and have lunch. I just want to kind of shamelessly plug my latest book, Human versus Computers, about people being stuck between bugs and stupid assumptions and stupid software. So if that's a topic you're interested in, kind of have a look at the book. Thank you very much.